we're back again in 7.2. I've got a little picture-in-picture going here, so you're going to have to give me some feedback on whether you like it or not. So we've got our essential understanding here. Review all this, make sure this all makes sense, but you should understand what a point, a line, and a plane are, so hopefully that's all some review. But when we talk about the prefix or the stem of a word being co means together. So when we talk about collinear points are points that are on the same line. Coplanar points are points that are on the same plane, and you can really have infinitely many of these. So when we start talking about naming points, lines, and planes, we get really specific with our notations, and because we're so specific with our notations, there's a lot of different ways that we're able to do this. So when we look at line RS actually has a bunch of different names that we could call it. So RS, right here, we can also see right here off to the side, this little cursive L, that is another way to name the line, because we can just say it's line L. We don't have to connect 2 points to make a line. We can just draw a line, because really it connects infinitely many points when we get deep into the theory behind the math. We also see that there's a point on the line Q that no one's talked about yet. No one's giving Q any love. So let's go ahead and say RQ is another way that we could name that line, or we could even call it QS. I mean, the ways are endless. You can turn around RQ to QR, you can turn around QS to SQ. There's a lot of different ways we can work with this. And if we want to be particular, because the line continues out forever, we would draw the arrows on the top of there. Now, you don't necessarily have to, but really this notation right here more so represents a line segment than it does a continuous line. So if you want to make sure that you're representing a continuous line, go ahead and have those arrows above or on the line that is above your points. B asks, what are 2 more ways to name plane P? So plane P is plane P because we see this P right here. It calls, it names the plane, and it doesn't attach to a point, so we know that must be what it is. But if we're really looking at renaming that, all a plane is a connection of 3 points that are not collinear. Because if I have 3 points that are all collinear, let's say R, Q, and S, that doesn't necessarily make a plane, it makes a line. If I have 3 points such as R, Q, and V, because now they make a triangle, they have to make a flat surface or a plane. So one way that we could rename plane P is RQV. Another way that we could rename it is just RSV, or any other combination of 3 points that are coplanar but not collinear. Now remember, point N is off limits because that is not on the plane, and same with point T, that is off limits because it is not on the plane. Question C asks, what are the names of 3 other collinear points? So 3 other collinear points. If I look at another line up here, well, I see that this line right here has 3 points that are all collinear. So T, Q, and N are all collinear on that other line that intersects plane P. And then it asks, what are 2 points that are not coplanar with points R, S, and V? We know R, S, and V are all on this plane, so they are part of plane P. So I've already pretty much covered it, but 2 other points not coplanar, that would be point T up here and point N down here. Moving on to practice question 1 here, we have named 3 collinear points. So if they're collinear, they're going to be coplanar. But they don't have to be on a plane that's actually shown. So take a second to think about that. 3 points that are collinear. There's actually only one option up here. Order can be changed, but the 3 points are E, B, and F. These are all collinear right there. Name 4 coplanar points. Well, I can essentially just say, well, E, B, and F, I'm going to clone that because they're all collinear. They are going to be coplanar, but the point I'm going to add with that, hopefully you can guess, is point G. Point G is also on the same plane there. So segments, rays, opposite rays. Segments and rays you should be familiar with. A segment is just a line that does not continue on forever. It's the from point to point. A ray continues on forever in one direction. Opposite rays, this is where people start to get mixed up. Opposite rays have to share the same endpoint and point opposite directions. So CB and CA are opposite rays, but CB and BC and change colors there. If I have CB and then BC, those are not opposite rays because they do not share the same endpoint. They both kind of have to start at the same endpoint. So notice if we have CA and CB, they have the same endpoint and they go opposite ways. But if we have CB and BC, those would not be opposite. So if I change that over to CA, then they are opposite rays. And scroll down so you can see the rest of this. So EF and FE form a line. Are they opposite rays? So let's go EF. Notice that the ray continues beyond the F because of my notation right here. It tells me it goes beyond the F. And then FE. So they are pointing in opposite directions, but the question is, are they opposite rays? Do they share the same endpoint? EF had the endpoint of E. FE had the endpoint of F, so no, they do not share the same endpoint. They are not opposite rays because of that not shared endpoint. So what are all the segments that we can name in the figure? Take a second. I bet you're going to miss some. I think you'll be able to figure out some of the segments, but I bet you're going to miss some. Easy ones. We see RS. It's the first one that we see. Then I like to take all my small ones first. So RS, ST, and TW, all my short segments. Now take your next size segments, connections of 2 of the previous segments. So now I'm going to connect RS with ST and make RT. Then I'm going to connect ST with TW and make SW. And of course with all of these we need the segment notation above them. Then I get my biggest ones, and that would be RW for the entire segment across. So you should end up with 6 segments there, and I believe that I got all of them, unless, of course, you could ask the question, well, what about WT or TS or turning around any of those? You could, of course, turn them around and get different names, but it's the same segment, so it's naming the segments, not changing the name. And then what are all the rays that we can name in the figure? Well, this is going to be a lot. So, well, I can't scroll too far. So one ray, and of course, how you notate with the arrow determines what direction it goes. So I'm going to start with endpoint R, and I could do, this writing's getting a little bit longer, so I could do RS, I could do RT, or I could do RW. Then I can start with S, and I can do ST or SW. Notice I'm going all the same direction right now. And then I could do TW, and that's all of the ones that could point right. So now if I come and point left, I could do WT, goes towards T, WS, going towards the S, WR, going towards R, and then I start working my way up, TS and TR, and then the only one left is SR, and I believe I've gotten all of them. Yep, so there should be a dozen different rays that you can name there in that line. So postulate 1, and with these postulates, it's not so much remembering what the postulate number is, it's remembering the content of the rule. So through any 2 points, there's exactly one line. That seems intuitive, but that is our first postulate in geometry. Through any 2 points, there's exactly one line that connects the 2 points. If 2 distinct lines intersect, they intersect at exactly 1 point. So this point C right here is that exactly 1 point, because if 2 lines, each line is straight, you can't intersect in more than 1 point because then it's not a line. You could have a parabola and a line intersect in multiple points, or a sine curve or something else, but if it's 2 lines, there's only 1 point where it intersects. And then 2 planes. If 2 planes are intersecting, so think about 2 pieces of paper or 2 anything else, there's exactly 1 line at that intersection. So right here, ST is the line at that intersection that connects plane, well, So we have plane STR and STW. Because the planes don't have names, we name them based off their points. So plane STR and STW there, they intersect at line ST. So now we talk about parallel, perpendicular, all those sort of things. So what are the names of two planes that intersect in BF? So first, I like to notate BF. BF is right here. So two planes that intersect in BF. Well, I see that BF is part of, let's add some colors. BF is part of this plane, BAEF, and BF is also part of this plane, BFGC. So those would be my two planes. We can say A, B, E, F, and plane BC, GF. And those are my two planes that intersect. And notice they both involve the B and the F, and they don't have to, I kind of actually put this in the wrong order. That should be A, B, F, E. And then B and F here at the beginning and the end, because they are those two endpoints. Why do you only need to find two common points to name the intersection of two distinct planes? Because there's really infinitely many points involved. I could put a point here, I could put a point here, I could put a point here, 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 here. Any line really contains infinitely many points because we can continue to zoom in and get more precise, more precise, more precise. So we only list 2 points because those 2 points indicate there's a line. By naming 2 points that are connected, we know that there's a line, so that's why we just say 2 points to name that intersection. If we move on to the intersections of plane QRS and RSW, well, I'm going to notate where are those. So QRS, so that would be this plane at the bottom, and then RSW, so RSW, that would be the plane right there. So name the intersection of the planes. You should already be able to see it based off the color coding, but those planes would intersect at RS. And if I tried to make a drawing of that, that would be like this plane, like that triangle, and this plane, that triangle. We see that they share this side right here. So RS would be the location where those 2 planes meet. Name 2 planes that intersect at QU. So what this tells you is that both planes should have to involve the QU. So I'm going to clear all my colors from over here. So QU is what we're looking to intersect at. So I'm just going to start and say QU and then choose another point to make my first plane. So let's say QUX. Come back here and make that triangle. And then I can make another plane. Let's say QU. Might as well choose R and do this triangle right here. So those two planes intersect at QU. You can see it from their names and on our image next to us there. What plane contains points L, M, and N? Shade the plane in the figure below. So L, M, and N. So L, M, and N. What plane contains points L, M, and N? Well, we could just name it that plane, L, M, and N. So I could actually connect M to N, and I could connect L to N, and I could connect M to L, and there's my plane right there. I have a diagonal plane that connects all 3 of those, and then shade it. So it would look something like that. What is the name, and you can't see all of this, well that stinks. What is the name of a line that is coplanar with JK and KL? See if I can get that right in the right place. Nope, so you're not going to see it, but it's JK and KL is what we're going for. So JK, KL. I like to highlight things so I can see it easier. So JK and then KL. And it's asking what is the name of a line that is coplanar with the both of them. So the easy way to do this is the line that's going to be coplanar with both is one that has been coded with both. So line JK is right here. I'm actually going to clear all this previous color. Sorry about that. So line JK right here, and line KL right here. So what is the name of a line that is coplanar with JK and KL? Oh, coplanar. This is why I wasn't understanding this. So if we make a plane out of JK and KL, we can see from our image here that we really can just look at the plane that is created by the top of the box. So we could just say ML. That back line right here is going to be coplanar. Or we could say MJ, and that would also be coplanar with JK and KL. So it's all about just look at it, see what we're really dealing with, and from there it normally kind of works itself out because we can see it. So try these on your own for a second if you haven't tried to work through these notes. So shade these planes, the plane that connects RVW and then the plane that connects UVW. So RVW, I've got RVW, so that is going to be this plane right here, or I can use the whole plane and just use RVWS, and I can just shade that whole side. So we could call it either the front or the right side, depending on what you want to call it. And then UVW, I see all of these are on the top of the shape, so I can just use the plane that is the top of that prism. And that is everything that we had from our notes today. So if you have any other questions, comments, or concerns, please let me know. But aside from that, we have our discussion board online and all of the other help tools. So hopefully you're all right with this, but let me know if I can be of any assistance. Have a great day.